breaking it down into 2 days. And just remember, today is the 19th. Okay, guys, here's what you need to remember. First of all, you only have 2 restrictions for domain in the universe, for us. In pre-cal, we want our domain to just be real numbers. And remember, what is domain? X values, inputs, all that kind of stuff. Also remember that you have no imaginary numbers. If I want real numbers, then I don't want imaginary. And if I don't want imaginary, then what does that mean? What does it have to be under there if I don't want imaginary? What is the answer to that? Do you guys remember? In algebra 2? It's 3i. It's 3i. And remember, I is imaginary. We don't want that. None of that. We don't want any i's. What's the answer to that? Why? Yeah, but I don't want this. So, that means no negative numbers under there. So for your roots, they must be positive. And can you take the square root of 0? You can. 0 doesn't have a sign, by the way, so it's not negative. So positive and 0. No negative numbers. No negative numbers. I'm sure that's like really bad grammar. Okay, that's one restriction. Here's your next restriction. This is a fraction. Here's your numerator. Here's your denominator. Denominator. Okay, so guys, you can have a negative down there. It's okay. Your denominator can be negative. Your denominator can be positive. But what can your denominator never be? 0. That's right. So this can never, ever, ever be 0. Those are the only 2 restrictions. If you do not see a square root or an even root, if you do not have a fraction, then your domain is always all real numbers, all of it. So, if I have something like this, when you copy that down, did you copy down a square root? When you copy that down, did you copy down a fraction bar? No. So if I ask you to state the domain, you don't have to think. It is negative infinity to positive infinity, always. However, that's not going to be the case for these next 2 examples. So let me kind of organize my work a little bit. And let's talk about how you're going to restrict the domains. That's going to be enough room. I'll just do 2 examples right here. Here's example 1. So on Friday, when you see that, it's going to say state the domain. State the domain for this function. It is a function. None of the x values are going to repeat. But I'm not going to ask you if it's a function or not. I'm going to ask you to state the domain. What do you know? What can that not be under there? Right, it cannot be negative. So if it cannot be negative, what does it have to be? Positive. And what's that one number that doesn't have a sign? 0. So what we're going to do is we're going to mathematically write just what you said. It has to be greater than or equal to 0. Let me move this up, and I'm going to make this a little bigger. Yeah, we're going to solve that. So when you are looking at a square root and I am asking you to state the domain, you're always going to use that symbol every time. Let's get rid of the square root symbol though. I don't like that symbol. I like that symbol, but I don't like that symbol. How do I make that symbol go away? Very good. We're going to square both sides in our head. What happens when you square this? What's the only thing that goes away? Yes. What's 0 times 0? So on the next line of your paper, please write this. All right, let's get x all by itself. So subtract 2 from both sides. Then we're going to divide by 3. Subtract 2 from both sides. And divide by 3. So I have x is greater than or equal to negative 2/3. Any questions on that answer? That is the domain, but guess what? You have to write it in interval notation. So if you're a little shaky on interval notation, graph it on a number line. I'm going to graph it on a number line. So a little simple number line just over here in my empty space. I'm going to write negative 2/3. I'm going to draw a circle around that. Do I color that circle in? Do I color this in? I do. Okay, let's go. We're going to color that in. And then, do I want my x's to be larger or smaller? The alligator mouth is open towards the bigger fish. So here's where x's get greater. So now that I see that, it's very clear to write that in interval notation. So my domain, my answer, is going to be a bracket with negative 2/3 all the way up to positive infinity. That is the only domain that I can have in there. If I wanted to do negative 3, it's not going to work because that's lower than negative 2/3. So this is your domain, and I'm telling you guys right now, you have to write it in interval notation if you want full credit on that question. Any questions on that? Okay, here's your other example. State the domain. That's what it'll say on your quiz on Friday. It's a fraction. Fractions can be negative, fractions can be positive. You just can't have 0 where? In the numerator? Can you have 0 in the numerator? Can you do 0 divided by 8? Yes. Yes, you can. Can you do 8 divided by 0? No, that's undefined. So when we go to state the restriction on this, remember, we don't care about the top. It doesn't matter to us. We just know that 3x squared plus 7x cannot equal 0. So this time, you're going to use the not equal symbol. Every time you have a fraction, you're going to use that. Every time you have an inequality, you're going to use that. Inequalities get that for square roots. Not equal signs get that for fractions. Not equal. We're going to solve this. What can I do with this over here? Only one thing. What can I take out of both of those? Let me recopy the rest of the problem. Inside is going to be, you tell me, what goes here? Yes, 3x, very good. Yeah, just a 7 because we took out the x. Now we're going to solve just like it was a regular problem. So set this factor to the not equals 0. Set this factor to the not equals 0. Oh, there's an answer. I know x cannot be 0. But that's not the only thing that x cannot be. If x turned out to be negative 7/3, I just solved, y'all. All I did. That would give you 0 also. Notice I did not box in those answers. I put bubbles around them because they're right, but I'm not finished. That's critical data, but I'm not finished. So in order to write that in interval notation, I'm just going to write on the screen because I ran out of room. Okay, here we go. So this is going to look like this. Whoop, I'm going to graph it. I'm going to graph this stuff on a number line. So I have 0. Here's 0. Here's negative 7/3. I'm going to draw circles around these. Do I color those in? Those are what we don't want. But everything else is fair game. All of that is part of the domain. All of this is part of the domain. And all of that is part of the domain. So answer, 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 skip, you're going to have a U. Answer, 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 skip, you're going to have another U. So to write this in interval notation, your domain is going to look like this. Negative infinity, all the way up to negative 7/3. I solved through my dot, so I'm going to close it off. I'm going to skip over 7/3. That's this right here. Pick right back up because there's shading in between negative 7/3 and 0. Ooh, I got to jump over 0. The U means you're going to jump. And guys, I ran out of room on my paper, so I'm just going to pick up where I left off. We just hopped over that 0 right here. So we're going to pick up at 0 and then go again to positive infinity. And that's your domain.